Bismillah. Today we are going to discuss about normal and tangential coordinates. Okay, like you have already studied the x and y coordinate, rectilinear coordinate, etc. And you know that r theta coordinate. Similarly, there is another coordinate system. It is called the normal and tangential coordinates. Sometimes we say n and t coordinate system. Okay. So I will give you some examples first, and then I will talk about the concepts in the normal and tangential coordinate system. Okay, so let's suppose this is a curvilinear path. Okay, basically normal and tangential coordinate system is applied in a curvilinear path. Okay, or where there is not a straight motion, there is a curve or circular motion. There you can apply n and t coordinates. Okay. So before I talk about this curvilinear path, let's talk about some concept. Okay. So what I will do here, first I will talk about the tangent. Okay. What is tangent first? So let's see. This is a circle and the center is here. Okay. And there is a point P here. Okay. I want to make a tangent over here. So in this case, what is the process? I will explain you. First, you have to find the center of point P. Okay, so this on this curve point P, so we know that the center is here for this curvature. Okay, so we will connect this point P with the center C, and then we will make a 90-degree line. Okay, this is called, this line is a tangent over this curve. Okay, at point P. Now the directions, suppose if this particle is moving towards this direction, in this direction. Okay, so our vector direction will be in this side. Okay, so this blue line is our tangent. Okay, tangent we call T. What about the normal? Where is the normal line? So this line which I created, dash line, is called normal. Okay, this is called normal. And so suppose I have a curve here, and here is the position or point P. I have to make a tangent on this point. Okay, so what I will do, first I will find where is the center for this curvature, and suppose this is a curvature C, so I will connect C with P. Then I will make a 90-degree line to this. Okay, this is 90-degree to this line. So this is a tangent T. Okay, and the line below or perpendicular to it is called normal line. Okay, and so now till now you got the concept of n and t. Okay, now suppose there is a car. Okay, and this car is moving on this curvilinear path. Okay, now if I want to ask you what will be the velocity vector at this point x. Okay, so what you will do, first you are going to find the center of this curvature for this segment. Okay, suppose for this segment the center is here. Okay, so in this case, again with the same concept, you are going to connect this, and then you will make a 90-degree line to it. So this will be the velocity vector of this car when it will reach at this point x. Okay, this is one concept. This velocity v will be in this direction, will be in tangential direction and in normal direction. This is the normal direction. Now about the sign convention, like you know that in x and y axis, this is x, and y-axis is on the right side you say it is positive and upside you say it is positive. Okay, now when you go downward direction you say that this is y negative, and on the left side you say this is minus x. Okay, similarly we have a concept here in the n and t coordinates. Okay, so I will explain you this also. Okay, here we go. This is our path. Okay, suppose this is a curvature. Okay, and the center of this curvature, this segment of curvature is here. Okay, so when I will connect for this point M, there will be n vector towards the center. Okay, and there will be perpendicular line to it, 90 degree. So suppose I'm talking about the velocity, you can say this is the vt, velocity in tangential direction, and this is the velocity in n direction, right? So as per our convention, we use in the direction of the motion we take the tangential direction as a positive. Okay, this will be positive, and normal is positive towards the center. When normal will or normal vector is moving towards or is directed towards the C center, so this is positive. Okay, if it will go up, then this will be called a negative direction. Okay, so this was the concept 2. Okay, now let's talk about the one more concept here. Okay, the third concept I'm talking about is about the curvilinear path. For example, this is a circle. Okay, you know that circle has a center. Okay, if I will ask you where is the center of this point P, you can easily say here is a center. If I will ask you where is the center for this M point, you can say center is same. For point L, the center is same. Okay, but what happens in actual curvilinear path like highway or any motion? Okay, these these curvilinear paths are broken in segments. Okay, for this segment we can say that center is here. Okay, the center is at this point. Okay, for this segment the segment is another, the center can be at this point. For this segment the center can be at this point. Okay, for this segment curvilinear path the center can be here. So in conclusion we can say that curvilinear path do not have a fixed center. Okay, it depends upon the segment of the curvature. Okay, now let's talk about the velocity vectors. Okay, so I will move up and I will talk about the how we draw velocity vectors. Okay, so suppose I'm going to make this is a straight line here, and there is a curvilinear path like this. Okay, and I am standing at this point. This is C point, and this is center of a small segment of path or curve. Okay, so suppose I'm talking about this segment, it starts from here to this point. Okay, so center I can connect this, and if C is the center of this path, this curvilinear path, so I can say this is radius r, this is also radius r. Okay, but in our book the convention is that we should use rho as a center radius. Okay, So I will write this is a rho is the radius of this path. Okay, so here we go. We see this is a uh, radius of this curvature. Suppose my car is here, and after some time it moves to the new place a dash. Okay, so I will ask you what is the velocity vector of the point A or the car at a point. So you can say easily using the previous concept as I talk about the tangent, then we will make a 90-degree to this line and then you will say here is the velocity vector of car which is at point A. Okay, now I'm going to ask you what is the velocity vector. Show me the velocity vector at the point A dash. So you will again make a 90-degree to this line and you can say this is the velocity vector, okay, for the point A dash. Okay, so based on these concepts we will try to find the displacement from A to A dash. Okay, once we get the displacement, you know that after it is easy for us to find the velocity and then acceleration using the time derivative. Okay, before we move to this relationship, let's talk about some fundamental thing. Like car is at point A and now it's going to move at A dash. So how much angle it makes? Suppose there is a small movement and the angle theta which traveled, we can write theta is equal to d beta. Okay, and this displacement from A to A dash is ds. Okay, so if you remember in your high school you studied that arc length is equal to r multiplied by theta angle. Okay, so in this case we see here displacement is A to A dash, it is ds. Okay, what about the radius of this curvature? So in this case we wrote that radius of curvature is rho. Okay, and theta, I wrote that theta is d beta. Okay, so we got a displacement equation now. Okay, based on this displacement equation we can easily calculate what speed. How? You can differentiate this equation and you can easily write velocity is d by dt of displacement s, or you can write ds upon dt. Okay, and as you know that ds upon dt is what? Rho d beta upon dt we can write here. Okay, and we can write rho and d by db by, d by dt of b is, we can write easily that this is a first time derivative of beta prime, so we can say it is beta prime. Okay, now guys, this is the speed. Okay, now let's talk about the velocity. Okay, you know that velocity is a vector quantity, but here till now we were just talking about the speed. So in that case we need to define the direction. So we will go back to this curve again. Okay, and let's see what I will do. I will put direction vector in this picture. Okay, so let's see, this is our vector v. Okay, we will say that this vector can be multiplied by unit direction vector et in tangential direction, and similarly this n vector we can add en here. Okay, so now our velocity v can be written as speed multiplied by et, the direction vector, direction unit vector. Okay, and we can say that our velocity is now equal to rho beta prime et. Okay, so here we have calculated the velocity equation. Now let's move to the next level and let's find the time derivative of velocity so we can find acceleration. So it is very easy for us. We will take one more time derivative, d by dt of what? Velocity. Okay, and we can write again d v et, okay, and upon dt. These are the vectors. Okay, so I should put the bar over here. So it is, I can write v after differentiation et, this is a vector term, plus v prime et. Now this equation becomes very interesting. Okay, why? Look guys, as you know that in x and y coordinate system we can write v vector is equal to vx plus vy. Acceleration is equal to ax plus ay. Similarly, in n and t coordinate system, okay, we can write v is equal to vn plus vt, okay, and acceleration a will be an plus at. Okay, so so here you can see that we can also define the velocity and acceleration. Okay, so we can write for the acceleration a is equal to v square upon rho en, okay, plus v e t. Okay, if you see, if you note here, this term is our an and this term is our at. Guys, we solved this equation and we derived it here. Okay, so in this case we can say that this term is an and this term is our at. Okay, now if I have to find magnitude and only I can write v square upon rho. Okay, rho is the radius of curvature and at is simple acceleration in tangential direction. Okay, and you can find the absolute magnitude by writing an square plus at square. Okay, now I will talk another concept about the acceleration direction. Okay, so let's go back to the picture again. Okay, suppose this is our x and this is a curvilinear path and there are 2 points a and b points. Okay, and here is a center. Okay, and there is a car at point A which is moving to the point B with some acceleration. Okay, so in this case I will make a velocity vector at this point A and velocity vector at B. Okay, now I will bring both vectors at the velocity vector which is at A and at B, and I will connect the tails. I will not change anything. I will just copy and paste these two vectors. Okay, so as you know that there was acceleration, so the velocity at B is increased. So I can say this is the velocity vector A and this is the vector B. Now I can connect this vector like here, you can see, and I will say this is change in the velocity. Okay, so I can write the velocity vector b is equal to velocity vector a, okay, and plus change in the velocity. Okay, now what is important concept is here, the direction of change in the velocity is also the direction of the acceleration, of total acceleration we can say. So it means that where is the total acceleration vector, it lies on the same plane, same place collinear to dv. Okay, this is our acceleration vector, total acceleration. Okay, now guys, it's very important, if you see that total acceleration is this a in green color, and on the right side I am drawing that at vector, and there is a an vector. Okay, now this should be 90-degree, but in my picture it's not correct, so I will make a like line here. This is at and this is an, and our a is here. Okay, so you will see that velocity is the acceleration at is in the direction of what, velocity. Okay, and the total acceleration a is in the direction of the dv. Okay, this is the important concept here. Guys, now let's move to the new concept. We are going to use n and t coordinate system on a circle. Okay, previously we were talking about the curvilinear path. Okay, but now we will apply the same concept on a circle. Okay, so let me draw a circle. Okay, here is a circle. Okay, and this is the center of this circle O. Okay, suppose this is a particle P which is moving in certain direction. Let me take like this is a tangent T. Okay, and this is an an, and this is at, and also velocity will be in the same direction. Why? Because you can see here that I made this velocity at, and v is in the same direction. Okay, so here you can see the velocity of this particle p and the at is in the same direction, right? Now we know that there is a radius of this circle, so we can say the radius of this circle r is equal to rho. Okay, we can change interchangeably. Okay, so in this case we can write the velocity of point P is equal to omega cross r. Omega is what? Angular velocity. Omega is here angular velocity. Okay, that is the radian per second is its unit. Okay, now guys, as we know that acceleration in the normal direction is v square upon rho. Okay, now you see that v is what, omega r, so I will write omega square and r square because it is v square upon rho is equal to r. Okay, so I will write r here. This will cut 1, so we can write n is equal to omega cross r. Okay, and for the at, you know that at is v prime. Okay, and v prime means d by dt of v, and v is what guys, v is omega r. Okay, so in that case I can write d by dt of what, omega r. Okay, now Omega is what? Angular velocity. So I can write d by dt of what? Angular velocity. So I can write omega is theta prime multiplied by r. R is a constant quantity, so r will be out and this will be theta double prime. So what do you see? That AT is equal to r theta prime. Okay, so I will color it that sorry, AT is equal to r theta double prime, and omega is what? An is equal to omega square r. Okay, so this is how we apply n and t coordinate in a circle or in a circular motion. Okay, so I will stop here, and in the okay, let me add one more thing here about the units. Okay, when I said angular velocity, guys, okay, so angular velocity is called omega. It is called ray. It is the unit is radian per second, or sometime we write degree per second. But remember here, very important, that we do not make any calculation in a degree per second. We always convert into radian per second. Okay, similarly for alpha I didn't discuss. This is angular acceleration. Angular acceleration. Okay, its unit is radian per second square. Okay, so these are the SI unit. Okay, and we always work in radians. Okay, to convert, if we have to convert from degree second to radian per second, okay, we have to multiply the degree by pi by 80. Okay, so if you have some degree, you can multiply by pi upon 1 by 80, so you will find degrees to radian per second.